Started. All right, so let's continue our lecture. Wow, there's a heavy rain and a traffic jam. I stuck on the road for like 1.5 hours. That's terrible. Anyway, so sorry for late for several minutes, and I would like to give you some brief summary for last 2 hours yesterday. All right. So yesterday we talked about the allowable stress and allowable loads, and the allowable stress means that the materials has some limitation. If your stress is exceed or greater than allowable stress, the material will break. All right. So you can see that there are several parts of the material has different criteria for the breaking. Okay. So in the end, we need to choose the smallest value. Okay, to determine its allowable load in this system. And then if we reverse, we can do the design for the system that you want, because you know the requirement, you know your requirements, right? So for example, to hand the W 5.4 K Newton is your requirement, right? So you bought a material, blue material here, and you design this shape of the sign holder, right? And then we need to determine the area, cross-section area for bar AB. And then in this problem, we introduce two important concepts. The first one is that you need to, maybe three. The first one is that you need to plot the correct force diagram and indicating the reaction force in the fixed support. Okay, so you see that there are two horizontal and vertical reaction force. Horizontal, vertical force. And then you see that at the beginning, you assume that positive direction, up and right. Okay, up and right. We assume that a positive direction. And then we do the force balance or moment balance. And then you can see that if this is negative, which, sorry.
Some of the students say he can't enter the live course.
Oh, really?
Yes. 右旋 and I can't enter it too.
Okay, maybe it's because I choose wrong one, maybe. Okay. How about now? So this one is not correct. I don't know why we have two of them. So maybe I just delete it. Add this series. Anyway. Okay, so the right hand side should be the right one. Okay. Is that okay now? I guess it is okay. Yoshun, yeah, I see you. Hi, can you hear me? 可以吗？有哈。Okay, so I will reshare my screen and then record again. Thanks for letting me know. Thank you very much. All right, so let's continue. Right. Okay, I just introduced that to the summary, okay? That we need to plot the correct force or loading diagram like this, because you need to plot the force you gave and also the boundary loading condition. You see this all set the boundary, okay, set at the boundary. And the fixation is vertical, horizontal, okay? And then we do the moment and force balance to solve all the unknowns. And also, the second important concept is that we set moment clockwise rotation about the origin you set is minus, and counterclockwise is positive, okay? And then after we do all of the unknown, and then we can proceed the next part. And also the third one, the third concept is that when as for the actual loading member, okay, actual loading member, if you acting the force at the tips of the actual loading member, the resultant force is always flow along the actual direction. So you can see that the loading is at the tips, right? And then the load is always follow the actual direction. Maybe you will ask, oh, why this is not along actual direction? Because it's in the middle, okay? And it will make the rotation of this. But if you are at a tip, it will move, right? Anyway, so the actual loading member, the resultant force always along the actual direction, okay? And then after that, we know all the force in the bar and at the pin. So you can have FAB and RC, and then you can determine the necessary cross section of the two devices. All right, this is what we learned from yesterday. And now we are going to learn, again, we introduce actual loaded members for chapter 2. And then we just use the equation that we know from senior high school, which is spring equation, F equal to Kx, okay? And then here we just use P equal to K delta, exactly the same, right? And then if we combine what we learned in chapter 1, and then we have delta equal to PL divided by AE. I think this is quite important because it's used quite a lot in the problems. All right, delta equal to PL divided by EA. And then if we just rearrange a little bit, we found that K equal to EA divided by L. So which means that the K is related to the material itself and also the geometry. All right, so then we talk about our first problem in chapter 2, and we introduce the first one of the important vocabulary, okay, rigid. Rigid means that undeformable, cannot be changed. There's no shape change, okay? But if you assign the Young's modulus, yeah, it means that it is deformable, right? And also we assume that in the elastic deformation region. All right, and also because of this rigid assumption, which means that you can easily determine the displacement relationship between each point. Okay, you can see A to A plot is 1 millimeter given by the problem, and then you can directly obtain its ratio by using the similar triangles, right? And then this problem still, using exactly the same concept that If you want to see the internal force of the bar, you just cut it, right? So if you want to know the loads at point B and C, you just cut it and then draw the figure, loading figure. We call free body diagram. Okay, load figure, just call it a real term. Okay, the official term name is free body diagram. Okay, 自由体图。力图其实就基本上就是中文我们都通常就我们画力图，但实际上官方说法叫做自由体图。Anyway， 他可能是想是说这个东西把它被切掉，感觉它是自由的，但是实际上它有力在那边，让它停住在这里。如果没有这些力的话，就会飞走，它很自由的。所以你要让它放在你前面的话，你就要把力加上去。Okay, I guess the free body diagram meaning is that because you're cutting, separating the part of the system, and then this part need to be free. And if you didn't put the force properly, if you didn't do that properly, the part will fly away because it's free. Okay, so again, we assume all the unknown force are opposite. Sorry, not opposite. Up, positive. Okay, and then we do the balance. You can see that we have -1. We assume that it's mistake, and then we can calculate the relationship of delta B and delta CE. And we're using similar triangle, we can get what is P. Now, new stuff from today. It's called bar with intermediate axial loads. Okay, again, it's still a prismatic bar. Okay, but it suffered from different load. Okay, so for example, apart from the force in the end tips of the bar, it also has multiple force in different direction, PB and PC. So it will become more difficult, right? How can we do that? It's difficult, right? Now, I will make it shorter, right? Shorter. It will be easier for us to draw a figure. Now, we want to know the total elongation, total displacement of this bar. So how can we do it? We need to sum them up, all the elongation from each section. Okay, each section. So which means that we need to know the displacement for AB part, BC part, CD part. Okay? How can we know the elongation? We need to know internal force. Internal force in AB, and then we can substitute PL divided by EA, and then we can know delta A, delta AB. So how can we know the internal force in AB? Again, cut it, right? We cut it. We cut it and we leave the upper part or lower part. It's all okay, okay? Now I'll give you an example for leaving the downside, the lower part. All right. So now let's take a look. After we cut it and we leave the lower side, we can see PD still there, PC still there, PB still there. But if you cut it, you need to have one force that balance all these three. Otherwise, it will fly away, right? Because previously you have the top part of the material, so it definitely give you something, right? So N1. I don't know the direction, so I just assume positive. All right? So you see N1 here must be there. And then to stabilize or make it equilibrium to stay here, to let you see it. Okay, so N1 is up. N1 plus PB minus PC minus PD equal to 0. And then we can shift all the rest of the term P to the right hand side. N1 equal to minus PB plus PC plus PD. Okay, so N1 is the internal force in the AB section. So now you can see that what I cut, the blue parts here, do you think I can cut a little bit higher or a little bit lower? Is that okay? Will I receive the same answer of N1 in a little bit higher or a little bit lower, as long as not reach A and point B? Is that correct? Correct? Do you want to give me an answer? Yes or no? Give me the... Can I just up a little bit or lower a little bit the cutting plan? Is that will receive the same answer or not? Anyone? 星汉，你已经回答了，要不要真正回答一下就可以得到 bonus？ 星汉，你觉得呢？ Yes. As long as this cutting plan is not exceeding here or A, because when you just slightly tweak it, slightly change the cutting plan, you will obtain exactly the same loading diagram. Okay, good, thank you. So can you give me your number, please? 1116. 13023. Yeah? Very good. So, that's it. How about the next? If I want to know the force, internal force in BC section, what should I do? I just cut it. All right? Cut it, and then again, leave the lower part. For example, okay? We see PC and we see PD, but now we don't see PB now, because PB is neglected, right? It is in the upper part. But now we have N2. We need to assume. So N2 minus PC minus PD equal to 0, because N2 is up, and PC, PD are downward, right? So N2 equal to PC plus PD. Finally, the third part for CD plan, internal force in CD part, CD section, you only see PD now, and you cannot see PC and PB, okay? So your N3 is PD. Now, you know that this section is, the internal force is N1, N2, N3 for AB and BC and CD respectively, right? So the delta 1 is N1 L1 divided by EA. Delta 2, N2 L2 divided by EA. Delta 3, N3 L3 divided by EA. Plus them together, you got total delta. So I believe you understand what I'm talking about. So you see how the bar divided by the boundary condition, by the loading condition. So depending on how many force, how many section that the force diagram will give you, and then you will know how many sections you need to calculate. Now here there are 3. Okay, if you understand this, I will give you an extra information. So maybe most of the your senior asked me, should I must, or have I don't know, Should I have to leave lower part? Can I leave upper part? Can I? Yes, we could. I will give you an example. Okay? So for example, from the beginning, if I cut AB plan, I'm not going to leave lower part. I'm going to leave upper part to see if we can get exactly the same value. Okay, so now if I leave upper part, it should look like this, right? And this combined together become, this and this plus together become the entire bar, right? So I leave upper part. So now, of course, this, we assume that is N1, right? Upward direction. Then, is that balanced? No, because there must be a reaction force on the ceiling, right? So what is the reaction force? We don't know, right? So RA, there's RA must be at the ceiling. So you need to plot this as well. Okay, it looks not correct, right? But it's okay. What is RA? RA equal to a, sorry, I should change a little bit. What's RA? RA is, let's see this figure. RA up. RA plus PB minus PC minus PD equal to 0. So RA equal to minus PB plus PC plus PD, right? So RA, now we know the value of RA. Let's take a look. RA plus N1 equal to 0. So this N1 equal to minus RA. And then you see it's minus RA, so which means that actually the direction you assume is wrong because of minus sign, right? So N1 equal to RA. So this N1 value equal to minus PB, PC, PD. And you see this direction and that direction is opposite, and the value are the same. Okay, so now I would like you to know that even if you cut it, no matter what happened, you can choose either way, either the part of it. Okay, both of them are okay. However, you need to, I mean, if I were you, I would choose the easier part. Okay, easier part, I will do the force balance. And also, I will choose that, systematically. All right, I won't do this. I won't do, divide this and leave down wall. Sorry, I won't divide here and leave up wall, and then the rest of them leave the lower part. It will kind of mess you up. Okay, so if I were you, if I choose to leave lower part, okay, everything is lower part. So it's making me easier to do the logical thinking. Right, if you can understand this, we can go the next one. Bar consisting of prismatic segments. So now it is not prismatic anymore. It becomes partially prismatic. Okay, so again, easy. This is a PA, and this is PA and PB. downward. Okay, so again we are going to get the total elongation. So again, I'm going to determine the delta at AB section. We know that we just cut it, right? Cut it and cut it. Okay, so this time I leave upper part, all right? Upper part. PA, N1, we assume upward, right? So N1 equal to PA, no problem, right? Because minus PA plus N1 equal to 0. This is the minus downward, this is positive upward. So N1 equal to PA, no problem. And divide by this, not divide by, just cut it and leave upper wall, upper part. And PA, PB, and N2 assume up. And then minus PA minus PB plus N2 equal to 0. So N2 equal to PA plus PB, no problem. So you see the delta 1 is N1 times L1 divided by E1 A1. So which means that even if this bar is different material, different length, it's okay, they are independent. Okay, N1 L1 divided by E1 A1, BC N2 L2 over E2 A2, and sum them up together, and you will get the total displacement. All right, so that's how it works. 其实我发现一件事情，就是我的耳朵啊越来越差了，所以我发现我讲话会越来越大声。对，我的耳朵一直从年轻的时候就开始不是很好，因为我爱听音乐很大声。然后现在我去做健康检查，然后我的耳朵的岁数大概是50几岁吧。对，然后有一些特定的音频我是听不到的，蛮糟糕的。Anyway, next one. Now, bar with continuously varying loads or dimensions. So if you have like a tower and with many sections, and each section may has its own force loading. So yeah, it's very simple, right? Delta I equal to NI LI EI AI. Okay, and then you just sum it up together. Very easy. How about this? If this section infinitesimally thin, you can treat that as a, gradually change, continuously change shape. So now the d delta will be mx. Well, sorry, this is not really good writing. So because this bracket is too big. All right. So sorry for that. Let me rewrite it again. Nx dx. All right. Times dx and divide by, and this is also incorrect. It should be ex ax. Okay. So you see that this is actually a function of x. N is a function of x. E is a function of x. A is a function of x. And dx is just a small increment. And don't worry about this, because if you want to get the total elongation, you need to do the integration. So your dx will be eliminating. All right. So suppose this also be L0 nx e x a x d x. All right, that's it. So when you see this figure, don't worry about this. All you need to do is going to find the function of n or e or a, okay? And then you can do the integration. Right, if you can understand what I'm talking about, I'm going to give you one example for next. This is called again, you see a system with rigid part, which is BDE. Okay, BDE is the rigid bar, which means that there's no deformation along it. But the rest of it, deformable, okay, with the E here. All right, so L1, L2, A1, A2, L1, L2, A1, A2, okay? And A equal to 700, B equal to 60, 25, and okay, P1 and P2. Where's P1 and P2? P1 is at the C point, and P2 is E point, which is 10 kN, 25 kN. And assume being BD is rigid, find delta C, which means that the total elongation of the bar. Okay? So now let's take a look. We need to know the point C, we need to know the internal force in this section, right? And also we need to know in this section, right? But before that, we need to know what is the load at point B. We don't know it yet, right? We don't know it yet. So how can we get the load at point B? The point B is, luckily, the point B also shared with this rigid bar. So we can use rigid bar to help us to determine the PB. Okay, the PB. So let's take a look. Okay, now P2 is downward, right? Firstly, we want to see this part. If we can balance this part, we can know force B, right? So we cut it. Okay? We are just separated for the first part, BDE separately. E is P2, and you see there's a support at D, so we don't know the reaction force. Okay, so we has a reaction force assumed up, okay, RD. And PB, we don't know. PB, what is PB? So we assume upward. And here, P3, well, I can give PB, all right? So we assume upward. And then we need to do the balance, okay, balance. Wait a minute. Okay, so now let's do the balance. Sigma MD equal to 0. All right, so let's take a look, which means that we just see this figure, okay? PB and times A, so which means that PB times A, which means that this is origin and this one is going to clockwise, so which means that this is minus PBA, okay? And then how about P2 minus P2. Wow, I shouldn't write down minus first, but I believe you know why. P2 rotate about the origin. D is clockwise. Clockwise means minus. All right, so equal to 0. And then it goes for PB equal to, well, I need to be consistent. PB equal to minus P2B divided by A equal to minus 25 times 625, 700 equal to 22.3 kN and minus. Okay, there's a minus sign here, which means that our assumption for PB is incorrect. Okay, incorrect. Right, that's it. That's it. Okay. Right. Then I'm going to take a look. Ask you to take a look here. Now, very important, very important. You already know that force at the point B is downward. And this point should be attached to this point, right? And if you attach them together, it should be the internal force, right? PB is internal force. The other is internal force too. So these two internal force combined together should be cancel each other. And you cannot see any force when they combine together because it is internal force. So now you know this part is downward and the 2.3 kN. How about, do you know anyone knows that what is the direction of this point, the force direction? Please. Upward, right? The value will be positive and also value 22. Okay, very nice. You say up, right? Very good, very good. So PB in the vertical parts should be upward, and this is PB and equal to 22.3. Thank you very much. So can you give me your number? 613 009. Very nice. Very good. So which means that you really understand the concept of this. This is really good. So because B and B need to attach together, so the internal force for these two parts should be opposite and with the same value, 2.3 kN, and downward, upward. Okay? So now you know that you know PB and you know P1, and then RA, what is RA? RA is the reaction force. We don't know it yet, right? So we need to we need to assume that upward. Okay? So next one, upward. Well, sorry, can I change a little bit to make it to the here, and I give right, so sigma Fy equal to 0 for this part, right? So how about let me give you can I give you a 1 for 1? Okay, and 2 and 2. So now you are going, you know which diagram that I'm going to talk about. Now, so RA is positive, and PB is positive as well. Okay, and minus P1 because P1 is downward. So RA equal to minus 12.3 kN. Oh, again, this is minus. So which means that I made a mistake. Okay, but it's okay. So now, sorry, I shouldn't using green. Let me change the other color. Because green one, I will use that later. How about pink? Sorry for that. One. All right, because green I will going to use later. So now we have the force RA, PB, and P1. So now we are ready to cut it to get the internal force. So this is the green part. Now, although I just ask you to say, normally I will prefer doing cut it and leave the same part, either lower part or upper part. Now I'm going to give you an example that we can actually, no matter what, upper part, lower part, it's okay. So now I'm going to show you, I'm going to pick up upper part. So upper part, 3, okay? 3. So you have upper part here. Okay, and you have RA, and you have N1. I don't know, so I just assume it's opposite. So sorry, positive, and then N1, and then we found that N1 equal to, so N1 equal to RA, right? And which means that you can see this figure. What is compression? This is a compression or tensile. Of course, compression, right? Compression. Because it's I and N1 is opposite. Okay? How about the fourth one? The fourth one is using blue. So we got 4. Now I choose bottom part. The bottom part is okay, alright? Although I said, I mean, if you are systematically thinking, you got systematical thinking, it's okay. Okay, so I got P1 and N2 up, right? We don't know the value. All right, so you see P1 equal to N2 equal to P1. So this is tensile. All right, so now you can do the delta, sorry, just one few minutes, delta C, okay? So you can determine the delta 1 and delta 2, I mean delta 1, delta 2, and then you can up, and then you know that this is compression should be minus, this is positive. And I will continue this lecture in next week. So see you later. So see you next week. Thank you. Bye-bye. If you have any questions, just come here. 训练怎么样？训练怎么样？
哪一个训练？
训练就是
说新资料的训练。
新资料你还在处理，对不对？
我还没弄。
没关系，没关系，没关系。你前一个做那么辛苦，做得很好，你觉得应该没办法再做更好，对不对？我说以目前的data来，
因为如果连年长老师那个原本对位方法都一样，那代表他们原本生产的就已经还不错了。
对。
那我们好像也没办法再做更。
没关系啊，反正我们就说，我们有叫什么完整的那个叙述 data 就好了。忘记录了。Stop recording.